Now, before we get too deep into digital tracks, let's just explain a few things. The purpose of an AC digital track is many things. AC, for a start, has a better flow through different rail conditions than DC does. Also, AC can travel a lot further, so you can set up some very long tracks, some very short tracks. If you're setting up a long track, you want it on high power. If you're setting up a short track, you want it on low power. But AC itself, the digital tracks, looks for a high and low frequency. It's not just one frequency, it's multiple frequencies. So it's looking for a high and low frequency. And it's constantly looking at those frequencies to see if they're both there. So say the upper side band, the lower side band of those particular frequencies. So it's looking for that, make sure it's still there. Now, as regards to tracks itself, if this is our railway, on a conventional track we'd have a block joint here. With these digital tracks, what we can do, we can put a feed in from our track tuning unit, and we can have another one at the other end. So this will be the TX, the transmit, and this will be the receive, and we'll call this one, say, frequency A. Now what you don't want to do is put another frequency A here, because if you can appreciate, these two could bleed through together, especially if we take this tuning unit off here. I'll give you an example here. Say this is frequency B, so we've got an A to B, and then here's another A. So TX, RX units, yeah. So let's just say, for instance, we take on a fault this out here and this unit out here, because we've got a fault on track B, and what happens is track A, if this is gone, will bleed through and inadvertently skip a track. So we don't want to go taking units out if we don't have to. But the way we lay it is A, B, and so on. And the other line here might be, say, C and D, C and D, and so on. So we don't get overlapping frequencies on the joining lines. The old TI-21 setup, again, there's analog and digital. The digital unit you'll see in this video. The analog is basically the same as the Asta unit, it's just the main box with the terminals on it. No digital equipment on that as such. You know, it's digital internally, electronic internally. So there's analog and digital. The digital you'll see in this video. But you couldn't use on the old system it through points and crossings, but you can on, I think it's every 400. On the new system you can do that now. So you can use it through points and crossings. And again, if this was another pair of lines over here, we would have opposing frequencies. So we'll go E and whatever, and so on, so on, so on. So we're not getting overlapping frequencies. On the track itself, what we will mention is you have, as I mentioned, track tuning units, TTUs. The leads of which are kept as straight and close as possible, because say this is an A and this is the B zone. Here you would normally traditionally have block joints. What you have is a zone between the end of this where the voltage starts to fall off rapidly to zero, the frequency, and on this one the voltage frequency will start to drop off rapidly to zero. Now you will get a slight bit of this where it overlaps technically, so this goes to here and this goes to here, but we will tune this zone when we set it up. That's our tuned zone between the two. And one thing to be really appreciated of is P-Way like to leave rails and things here, and if you leave rails there, that affects the tune zone, because obviously metal inducts, so it can also cause several problems there, so you got to be careful it doesn't induct and drag the tune zone even further. So just a few little things basically there to mention about TI-21s. Again, all of this is off the internet. There are many sources on the internet around the world that mention how TI-21s work, so there's nothing new there. It's all on the internet. But that's just a little bit of a basic setup there, so you understand some of the principles of it before we get into the actual video. Right, drawing board time. Digital frequency tracks. We've already discussed some of the basics. You don't have the same frequency side by side, you have separate frequencies. Also you have high and low harmonics in the frequency, so it's not just looking for one particular frequency, because you could have, say, a spurious frequency from out there some equipment line side that's nothing to do with the railway that could be interfering with it, so it's looking for the top and bottom frequencies. But what is the actual digital track itself? Basics of the equipment. We have our load cupboard at the feed end. We have our load cupboard at the relay end. With our relay in there. In our feed end we have our power supply unit, our PSU. We also have a PSU at the far end. The PSU feeds our transmitter called the TX. Normally fed with 24 volts, and then the TX creates the frequency that goes to the TTU, track tuning unit. Our pair of wires out onto the rails. This is our rail line. As such, and our TTU then connects to the rails. At the far end of the track, again we have another TTU. This creates our tune zone, our track circuit, because remember there's no joints in this system, unlike the conventional track circuits where we have insulated block joints. We connect onto our rails again, and then our TTU feeds into our receiver, our RX. Now, our receiver outputs a voltage 40 to 44, 46 volts that goes and feeds our track relay, repeating back to the interlocking.
I'll see you in a bit.
So, what we have here, our next track then will have another TTU here. And that will go on to the next and so on and so on and so on. And nominally, within 5 meters of this end tune zone, our voltage will completely dissipate down. It won't go beyond there. So that sets up our zones for our track circuits. Again, if we get to the very end of this and we are now abutting a normal track, or we have no more tracks beyond that, we can put an ETU, an end termination unit in. And that end termination unit defines the end of the track circuit. Also, what we'll probably have beyond there is shorting straps, a couple of them, to make sure that nothing goes beyond. Because what you don't want is this feeding miles and miles and miles away through a set of points on the other end of some tunnel somewhere. And that is the basics of our digital track. Whether it be Aster, HVI, Jumont, which is a French system. With them you get a high impulse, high voltage pulse on the track circuit. A little bit different than this. That tends to be in sidings to get through rust on the rails, etc., of little used lines, instead of tutetic strips. And also we have our TI-21, TAC 200s, 400s, and there's other systems beyond that as well. And that's explained more in the video as we go along. That is our basic digital track circuit. On the actual power supply unit, here we have the incoming 110 on our left hand side on this moulded plug coupler with our settings, and we also have an earth terminal, and on our outgoing side we have a B24 and N24 outputs. Then we have some current settings and a common tap off. We have a healthy state DC on light at the top as well, so this supplies our power to drive the receiver itself. This is a transmitter unit off a style H TI-21 unit, and what we have here, we have our positive and negative 24 volt feeds, and we have our output 1s and 2s to the tracks. Now our connection out to the track itself is protected with a lightning arrestor there. Our incoming outcoming lines on the top there are strapped to our posi and negi legs off our rails, and we have an earth connection there that goes into the earth connection in the ground. And how this works is simply, this is a very high resistance open circuit, and when it receives something in excess of a lightning voltage or a critical voltage, the circuit will break down across that lightning arrestor there. So the middle portion, which is connected to the earth, is never connected to the top or bottom. It's a gas discharge arrestor. So when you get an incredibly high rupture voltage there, it will break across the top to the middle or the bottom to the middle and go straight to earth to protect the electronic equipment. So here we have the receiver unit, and we can see a few things to start with on the receiver unit. We have the frequency key, which dictates the frequency it looks at. That's also on the lanyard there, receiver A. We have a small visual display unit, which we can use to get the data and information for our incoming voltages, etc. We have our 24 volt supply, positive and negative, coming in. Then we have our relay connections down at the bottom, our inputs, and a safety earth wire off. And our buttons upon the unit allow us to go forwards and backwards through the system, so we can see that the relay is picked, it's energized. System is energized, that will feed our normal track relay out. With 40 odd volts, 50 volts relay. So if we click next, we can see that the current is now average current, and we can see 62 milliamps. We can watch that. Go back, so we'll go on to the next one. We can see the threshold, so the drop away is 48.4, at which it will operate. Go back, we see the voltage of the power supply unit, 27.7, that's the incoming 27 volts. And the voltage out to drive the relay, 41, 42 volts. It's about tea time now, so there's a slight bit of fluctuation. Everybody's using their kettles at home. And power out, 1.8 amps. Temperature, the unit you can also look at, 41 degrees. They are electronic units at the end of the day. And the status, it is okay, the system is healthy. Configuration, the frequency, 1699. That's the frequency of the actual unit, 1699 hertz, kilohertz. That's the operating frequency that it's looking for on the track circuit itself. And then we've got sideband readings, which we can go into as well. And there's other bits of information in there as well. Configuration, which we've already done. And we're back to start again. Now here what we have side by side, we have a Aster tuning unit with a particular frequency, and here we have a TI-21 end termination unit, as we've just seen. As you can see, exactly the same mouldings. This is just newer, this is the older system. They have a small mounting hole in the rear, so that you can actually mount these to a stake that goes in the ground, and some cleats, so you can actually secure the cables coming in. You can see your access cable ways there for your track links, your cables coming in. Now this is one of our tuning units, our ETUs, or end termination units, and you can also get air core transformers, because you can have centre fed tracks as well. And these are moulded plastic bodies. The inside of this is foam inserted around the transformer coil that's inside there. And these giant lugs here with the locking nuts are going onto the actual rails, so you have your termination cables coming through the holes in the bottom of this onto the rails that way, and then this way they go onto the nuts, and then you have extra locking nuts on top. And these are torque set, so they don't come loose. The other thing about the leads is the leads are kept as close together and as straight from the rails so this is possible, because if you don't want an imbalance in the leads of say a metre extra on one side, a metre less on the other, because that will affect the tuning zones, etc. of the operation of the system. We have some small tapping off settings inside there as well for the power supplies, so that's also part of the circuit. As you mentioned, T1 and T2 for your lead connections. There is a lot of information under the lid there, I'm not going to show you. And usually these have a label on with the frequency, so they'll tell you what frequency they are. On this one, on the top, it actually gives you the frequency of 2300 Hertz for a 2300 Hertz track. The leads themselves to the rails come pre-moulded. These are pre-made ones. Heat shrink on the end and a proper industrial strength crimp lug on the end. So that's your track connections. Now I mentioned Asters, and Asters were the forerunners long before the TI-21s. And Asters, pretty similar system. Here we have some of the old units, some more over there, all different frequencies. And as you can see, this one is a style UT, and the serial number, etc., and the frequency on it. This is a 1460, I think it is. But we also have here another frequency, a 2600 Hertz units, and these need to be matched, so you have a transmitter and a receiver unit. So in this case, this is a transmitter, this is a receiver. These are different non-matched units. I've just picked them off the shelf just to show you. And over here we have another design. We have an SF style, so you see the different colour again, and again frequency 2300. So this is the transmitter. In this case we have its matched receiver, again SF style, frequency 2300 Hertz. So those two are matched. So between the different styles you've got various little bits and pieces, and of course just on the top there an EBI 200 power supply unit, just to show you. It's the same casing, just newer equipment. So instead of having the screw terminals, you have the plug coupler. And again on the Asters you have the ability on here to set up various straps to give you the different power and settings. You don't so much have that on the EBI tracks. What you do have is a high and low power setting. The much more modern system. The old Aster units use simply same as on the power supplies. You have your track outputs on your transmitter, so you've got your T1, T2 links that go to your T1, T2 that you saw on the grey boxes, and you have your positive 24 and negative 24, and then you've got some settings as well to the G, which is a common. So on this you would just have your common and you have your power supplies. And again at the receiver end you've got your setup straps, your R1 and R2 that go out, R1 and R2 that come in off your track, and your T1, T2 transmit that goes out to your relay to drive your relay itself. So you've got your receiver settings, your relay settings, your T1, T2 settings, and your positive and negative and your 24s. Right, one last thing to mention about Asters and TI-21s, and it's not something people are readily familiar with, is the whistling noise you hear that's coupled with these track circuits. Now, earlier in the video I mentioned that obviously we don't just use one frequency for this track for safety reasons, we use two. So let's just say for instance we use a frequency up here, I'll call this frequency A. Our second part will be frequency B, and this will resonate back and forth. So we'll have an A, B and so on. So our frequency will do this, a bit like a square wave or a sine wave. And what our receiver will be looking for is this frequency A within its limits, within its threshold. Again, frequency B within its threshold, frequency A within its threshold, and so on. And this is happening that quickly that what you're getting is a whistling noise. So that whistling noise you hear, that warbling whistling noise, is a combination of the two frequencies happening. And you can hear that landside. It's actually in the notes to listen out for the whistling frequency. And it depends on the strength of the unit, the length of the track circuit, the frequency as well. Different frequencies, different sounds. But that's what the warbling sound associated with the track tuning units is about. You will hear this if you ever work on a track that's digital, TI-21 or Asters, especially Asters. Asters whistle quite loudly, but that's what that is. It's looking for that up and down, that high and low thresholds on its frequencies as part of that track circuit. So whilst there are 4 key frequencies for the track circuits themselves, they have threshold values between the high and lows that the system must look for. Outside of those, that's it. The system says, I'm not happy, and drops the track. So again, safety related.